Hi, welcome to this module, and in the last module what we have seen how we can use operational amplifier, as the inverting amplifier, right, how we can use op amp as inverting amplifier. Now in this module let us see how we can use op amp as non inverting amplifier. Okay. So let us see how op amp can be used as a non inverting amplifier. So let us come back on the screen and you will see the circuit. Here what is the case? The case is that we have applied the input voltage or we have applied the signal to the non inverting terminal of the operation amplifier, as you can see here, right. We still have the feedback resistors R1 and R2, we still have feedback resistors R1 and R2, and here the inverting terminal is grounded, non inverting terminal is given the signal. Okay. So if I see the non inverting closed loop configuration, first is external components R1 and R2 forms a closed loop, right. First point is that external components R1 and R2 forms the closed loop, it is similar to the inverting amplifier. Second is output is feedback to the inverting input, output here is feedback to the inverting input, correct. Third, input signal is applied from the non inverting terminal, input signal is applied from the non inverting terminal, right. All three things we understand, very easy, right, super easy to understand. One is R1 and R2 forms a closed loop, second the inverting input is grounded and output is fed to the inverting input, third is the input signal is given to the non inverting op amp. Now non inverting op amp using ideal configuration, if it is ideal then we have required conditions to apply for virtual short for op amp circuit is negative feedback and infinite open loop gain, right. Now closed loop gain G is nothing but VO by Vi is 1 plus R2 by R1. Now this we already know, it is a very basic. So let us see, R1 is here which is grounded, right, R2 is here, and then because of the virtual ground concept we have difference voltage 0, the whatever voltage is at this non inverting terminal, same voltage you will have at the inverting terminal because of the concept of virtual ground. Now if I see that, then what will I find, that this current here is nothing but V by R1, here will be V by R1, VID equals to 0 volts, or what we can further find it, that VO is nothing but VO will be V1 plus V1 by R1 into R2, right, V1 by R1 into R2. This is nothing but, if I have V1 common, then V1 common 1 plus R2 by R1, right, 1 plus R2 by R1. So my VO is nothing but 1 plus R2 by R1, alright. This is my output voltage which is 1 plus R2 by R1, alright. So this is what is closed loop gain. Infinite differential gain we have seen is nothing but it should be 0. Infinite input impedance is V1 minus V minus divided by R1, right, because R1 is the input. 0 output impedance will be output voltage. Closed loop gain depends entirely on external passive components, that is we have seen what does it mean by external passive components. Then we have seen closed loop amplifier trades gain, we have also seen this exactly similar concept in the inverting inverting amplifier. So equivalent circuit model, if I want to draw, input impedance is infinite, right, output the gain is 1 plus R2 by R1 into V, output voltage we have written here, output impedance is 0, gain is nothing but 1 plus R2 by R1, gain is nothing but 1 plus R2 by R1. So you have to remember that the most of the things are similar to the inverting amplifier, except that now since the input is applied to the non inverting terminal, my output signal would be in phase to the input signal. That means if I apply an input signal at this particular terminal, right, my output will be amplified but in phase, right. So this is 0 degree, this is also 0 degree, this is output is in phase when you compare with the input signal, alright. That is why it is non inverting, it is a non inverting amplifier. So, let us take an example, of non inverting op amp, alright. So, find the closed loop gain of following non inverting amplifier circuit if Rf equals to 100 kilo ohm, Rn equals to 10 kilo ohm. We have Rf value, we have Rin value, right. Now, what is the formula? Formula for non inverting amplifier is 1 plus Rf by Rin, this is gain, right, and if I have VO, then VO will be nothing but V 1 plus Rf by Rin into V in, right. This is my formula for non inverting amplifier, correct. So, given Rf equals to 100 kilo ohm, which is given here, R1 is 10 kilo ohm, AV or V gain, right, is 1 plus Rf by Rin. So, if I put the value of Rf and Rin, I have AV equals to 1 plus 100 by 10. So, 100 by 10 is what? 10. So, 1 plus 10 is nothing but 11. 11 plus 10 is nothing but 11. Therefore, the closed loop gain of the inverting amplifier circuit is 11 or 20.8 dB. This we can get by substituting value of by converting the value of gain into decibels by using 20 log of gain, 20 log of gain or 20 log of 11, which is equal to 20.8 decibel. Easy, super easy, right, because you have to just substitute the value of the resistors in the given equation. So, let us find another let us solve another problem. Okay. So, this problem is that the gain of the original circuit is increased to be 40. You see similar example, right. Find the values of resistors, required. So, given AV equals to 40, we know that AV the gain is nothing but 1 plus Rf by Rin, or 40 equals to 1 plus Rf by Rin. Rin is 10 kilo ohm. So, Rf can be 390 kilo ohm, right. Rf can be 390 kilo ohm. This is super easy to understand. And that is why let us move to the next problem. The next problem is calculate the voltage gain of for each stage of this amplifier circuit, both as ratio and in units of decibel, then calculate the overall voltage gain. So, you have given amplifier like this. You see there are two stages here, we are applying the input at the non inverting terminal and the output is again applied to the another amplifier at the non inverting input, right. The output of the first amplifier is fed to the input of the non inverting terminal of the second op amp, right. Here what we are asked? We are asked to find the value of AV, we are asked to find the value of overall voltage gain and also the voltage gain for each stage, okay. So, you see a circuit may look complex, but the solution is very easy. Now, you see just stage 1, is what? Non inverting amplifier. Non inverting amplifier, what is the formula? Formula is 1 plus Rf by R1, right. So, what is Rf? 3.3, R1 4.7. So, AV equals to 1 plus 3 by 3 divided by 4.7 is nothing but 1.702. Let us consider stage 2. What is formula? 1 plus Rf by R1. AV equals to 1 plus 9.1 divided by 2.2 equals to 4.136, because 9.1 divided by 2.2 will give us 3.136. 3.136 plus 1 will be 4.136. So, we now know AV2 as well, right. So, if I convert my AV1 into decibels, it is 20 log 1.702 or it will be 4.6 decibels. If I convert my AV2 into decibels, I will have 20 log 4.136 or 12.3 decibel, correct. Therefore, the overall gain of the non inverting amplifier is AV1 into AV2 is 1.702 into 4.136 equal to 7. Now, again I want to convert my gain in decibels, then I had to use 20 log 7, that will give me value of 16.9 decibels, right. This is how we can find the solution for the non inverting amplifier given a problem to you, Okay. So, in the next module what we will see? In the next module we will see how we can solve the summing how we can solve the differential amplifier, right. What we have seen earlier, inverting, then we have seen summing, then we have seen non inverting amplifier, right. Now let us see in the next module what exactly a differential amplifier means. Okay. Till then you just look at this module, understand how the non-inverting amplifier works, or how you can design the op amp as a non-inverting amplifier circuit, how you can design op amp as an inverting amplifier circuit, how you can design op amp as a summing amplifier. Alright. Till then you take care, I will see you in the next class.